So first, ang hirap kasing mag-discuss, it's very difficult to discuss a certain framework if, in the first place, we don't know what is mathematics. What I'm going to give to you is a working definition that I use para ma-define natin yung mathematics. Without a working definition, it's very hard to start the career sa mathematics. Okay? Unang-una, walang generally accepted definition ng mathematics. Wala talaga. Okay? But going back to the time of the Greeks, okay, mathematics came from the Greek word mathema, which means learning. Okay? Learning. So medyo general. Okay? Although the definition of mathematics nag-evolve na siya, so currently what most of the mathematicians are using in terms of the definition of mathematics is this, which is it is also my definition of mathematics. Mathematics is the study of patterns. Okay? Mathematics is study of patterns. However, medyo lalagyan ko lang ng konting details yung definition na to. Okay? Mathematics is the systematic study of patterns. Okay? Based on what? Based on logic. And the kind of logic that we're using in mathematics is deductive logic. Okay? So mathematics is the systematic study of patterns based on deductive logic. And this is the working definition that I use sa aking career as a mathematician. Okay? So without a working definition, medyo baka maging lost tayo kung ano yung tinuturo natin. So I don't know if you are also going to use this definition, but for me, this is working para ma-push ko yung aking teaching career sa math, yung aking research career sa math, and my advocacies in promoting applied mathematics to the whole Philippines. Okay? Now, isa-isahin ko yung definition kanina. First, sinabi ko kanina that mathematics is the systematic study of patterns. So, anong ibig sabihin ko dun sa word na systematic? It means mathematics is a formal language. Formal. With accepted rules and grammar. So, kung titingnan natin, hindi pwedeng basta-basta ka na lang magsulat ng isang mathematical solution, right? So, tinuturo sa school kung ano yung tamang way how to solve problems using the language of mathematics because mathematics is a formal language. Now, meron akong papakita sa inyo. Okay. So, I'm teaching Math 10 in UPLB. The course title of that Math 10 is Math, Culture, and Society. Then, isa sa mga first exercises ko, may pinasagutan ako sa kanila. Compute. Ano ang sagot dito? 6/2 tapos quantity 2 plus 1. What is your answer? So maraming nagsagot 9. So I thought na baka maraming magsasagot ng 9. But nagulat ako. Maraming nagsagot din ng 1. Okay? At halos malapit-lapit na rin yung 17 sa 22, right? So medyo naglalaban sila. So ano ba talaga yung tamang sagot? And nakikita natin to sa Facebook. Nakikita nyo, di ba? Maraming nagsishare. Ano ba talagang tamang sagot? Tapos ang daming nagdi-debate. And I saw people na math teacher versus math teacher. Magkaiba yung sagot nila. Okay? Just weird. Okay? So sabi ko, why not i-Google natin? So I asked Google, hindi ko natanong kay Siri, pero tinas ko kay Google. So sabi ko, tinype ko, mismong yung problem na yon. Kasi di ba sa Google search, if tinype mo yung equation, magsasagot din talaga siya. Meron siyang ganong app. Okay? So, tinype ko yun, 6/2, quantity 2 plus 1. Ang sagot ni Google, 9. Pero, the thing about this is, very smart si Google. Hindi niya kinompute diretso ito. May ginawa siya. 6/2, nilagyan niya ng parenthesis. Yung 6/2 doon, bago niya minultiply doon sa 2 plus 1. Okay? Very smart si Google. Why? Again, as I've told you, mathematics is a language. And if we're talking to each other, mas maganda, malinaw kung ano yung pinag-uusapan natin. And dito, Google actually clarified na yung sinasagutan niya is this. Okay? So what is my point here? Ang point ko dito, walang lugar sa mathematics yung mga vague problems. We need to clarify ano ba talaga yung gusto nating sabihin. Why? Because mathematics is a language. Okay? Magbibigay ako ng isang example. Sino dito, lahat dito taga Laguna, right? Okay? Taga Santa Cruz, Laguna po ako. So kapag nag-uusap kami sa Santa Cruz, Laguna, maraming mga sinasabi nila na mali yung grammar in terms of the language na Filipino. Example, so pag tinanong ko, do you eat fish? Tatanong ng isang taga Santa Cruz, ang tanong niya, nakain ka ba ng isda? Okay? Kung nag-uusap lang tayo as taga Santa Cruz, I understand na ang ibig sabihin mo na do you eat fish? Pero kapag may nakarinig niyan, parang ibig sabihin sa kanya, yung isda ang kumain sa akin. Right? So, that's the same way with mathematics. We need to clarify ano yung question natin. Okay? Because mathematics is a language. Okay? So, that's the first point there na sana yung mga questions natin ma-clarify. Although yung iba makipag-debate, sir, di ba may MDAS naman? Bakit hindi na yung gamitin natin? Ang gusto ko lang sabihin dito, na sa simula pa lang, i-clarify na natin. Okay? Because this problem, I think, is not a mathematical problem, but more on the language game. Okay? So, that's the first point. The second part is the study of patterns. Mathematics is the study of patterns of objects and the relations among those objects, whether physical or abstract. Okay? So, kahit anong patterns. May mga nagsagot kanina, mathematics is about numbers, which is somehow siguro true, but nagkataon lang, ang mga numbers ay may pattern. That's why we study numbers. But mathematics can study other things, other objects, other than numbers. Okay? So, example, you can study the patterns dun sa communication, sa relationship among people. You can study that system using mathematics. Or the different patterns sa wallpaper. Okay, symmetries. So there are many patterns na pwede nating aralin kahit hindi about numbers. Okay? So that's the thing about mathematics. And ang kagandahan dito, alam natin na in real life, sa natural world, maraming patterns. Okay? So since maraming patterns sa paligid natin, artificial man yan or sa nature, ibig sabihin, pwede nating pag-aralan yon using mathematics. And that's also the good thing because ibig sabihin nun, we can use mathematics to solve real-world problems. Basta ma-detect natin yung pattern, we can provide possible solutions. Okay, ano-ano yung mga pwede natin gawin? First, we can describe structures. Okay? Pag sinabi, can you describe that table? Di ba, medyo mas magandang ma-describe natin siya na may gamit ng mathematics. Circular, tapos may height siya, yung radius ng table yung sa taas, right? So we can explain using mathematics. Okay? We can describe structures, we can describe objects. Another one is we can explain phenomenon. Example, bakit bumabaha sa Venice ngayon? Although we can explain that using physics, using environmental science, but we know na dun sa mga studies nila, they have quantitative explanations. Okay? They have simulations probably, computer simulations na gumagamit ng mathematics. So we can explain phenomenon, mga different phenomena, using the language of mathematics. We can predict scenarios. Example, yayaman ba ako pag tumaya ako sa loto? Of course, yayaman ka. What I mean is, mananalo ba ako sa loto? What is the probability? So, kaya mong i-compute ngayon. Okay? Or, pag nag-invest ba ako ngayon sa stock market, can I forecast magkano yung kikitain ko after 5 years? Okay? So, I can predict using mathematics. And the last one, I think, is the most important contribution of mathematics is we can prescribe solutions to problems. Example, traffic sa EDSA, that's a problem. Wag na lang tayong lumayo sa EDSA, SLEX na lang. SLEX. Traffic sa SLEX. Or hindi pala, lalayo pa ang SLEX. Traffic sa junction. Okay? Diyan sa Jollibee, traffic. So ano yung mga pwede nating solutions? So what we can do siguro sa simula, mag-simulate. We do computer simulations. I think this strategy will not work. This strategy will work based on my simulations. And the good thing with simulation is, ini-implement lang natin siya sa computer. Hindi natin ginagambala yung everyday life ng mga tao. Kasi di ba minsan, yung mga nag-i-implement ng policies, ang simulation nila, actual. Doon mismo ginagawa. Eh di maraming naapektuhan. Siguro before gawin yung actual simulation, why not we do computer simulations first? Mathematical simulations. Okay? So ito yung mga bagay na because we can find patterns around us using mathematics, pwede nating sagutan yung mga problems na to. Okay? Yung mga real-world problems. Okay, another one. Because of mathematics, we have now technological wonders. Cellphone, computer. Okay, kaya nga sabi nila, mathematics is the foundation of many sciences. Sabi rin nila, mathematics is the queen of the sciences. Nagtanong ako sa mga estudyante ko sa Math 10. Yung Math 10 kasi from different degree programs yon. Okay, so iba-iba. So tinanong sila, tingin nyo ba ang mathematics ay pampahirap sa buhay? Ano tingin nyo sagot nila? Siyempre, yes. Okay. Bakit ko ba inaaral yung x squared plus 2 equals 0? Para saan ba yan? Okay? So, inisip nila na, yeah, pampahirap nga sa buhay yun. Baka hindi ko naman kailangan. Pero tinanong ko sila, what do you think is more difficult? Wala kang cellphone ngayon or yung mag-aral ka ng mathematics? Isip nila, mahirap na walang cellphone ngayon. O kung wala kang laptop ngayon, di ba parang hindi comfortable yung life? And yung mga cellphone, laptop, yung mga technologies natin ngayon, of course, pinagsama-samang different areas yan ng sciences and engineering. But kung titingnan natin, isa sa mga foundations niyan ay mathematics. So without the mathematics, wala tayong mga gamit ngayon, mga gadget. And mas mahirap ang buhay. Right? So baka ngayon, kung walang mathematics, nag-aaway-away tayo, chaotic masyado. Okay? Kasi wala tayong way how to exchange money. Okay? So, there are things na kala natin, mathematics is so difficult, pero pag binalikan natin kung ano yung mga nagawa ng mathematics, iisipin natin, ay, mas pinadali pa ng mathematics yung life natin ngayon. Okay? So, that's another point. Now, mathematics can be a brain stimulus. So before I worked sa UPLB as a teacher, nag-work muna ako after my graduation sa BS sa isang insurance company as a corporate planner. Okay? And then, doon sa company na yon, may boss ako. Lahat kami pala doon sa corporate planning staff, graduate ng math. BS Math, BS Applied Math. So lahat kami, taga-math. Okay? Then yung boss ko doon, na kung alam niyo yung work ng isang corporate planning, sort of we are the sort of the brain of the company. We create strategies for the company, investment, marketing, ganyan. So kami ay yung parang sort of brain, okay, ng company. And then what we do every day ay nag-uusap kami, we create strategies. So sabi ng boss ko, so nung everyday na pumapasok ako doon sa company na yon, yung boss ko, lagi siyang nagsasagot ng Sudoku. Everyday. Parang 6 a.m. pa lang nagsasagot na siya. Early in that morning. So, sabi ko, boss, bakit ka ba everyday nagsasagot niyan? Sabi niya, kasi yung paggawa na itong mga Sudoku, yung mga puzzles, nai-stimulate yung brain ko. And magandang ma-stimulate yung brain ko early in the morning para pag nag-meeting tayo, we create strategies, mas maganda yung output. Okay? So mathematics can also be used as a brain stimulus. Okay. Now, dun sa another part ng definition ng what is mathematics, sabi ko, mathematics is the systematic study of patterns based on deductive logic. Okay? So ang ibig sabihin lang nito that mathematics has a philosophical foundation. Okay? May philosophy behind dun sa mga inaaral natin sa mathematics. From axioms to theorems, etc. Okay? And I want to provide you a certain idea about this deductive logic. Okay? Kapag nagtuturo tayo ng math, syempre sinasabi natin, ito yung mga axioms, tas from the axioms, makikreate yung theorems. Okay? Kasi di ba, ang idea ng deductive, you have different set of premises, then from there, you will deduce the conclusion. Without using yung kabaliktaran naman deductive na inductive, na nagbibigay ka ng mga additional, then magde-generalize ka, hindi. So dito, you have certain premises, then you create the conclusion. Kaya lang madalas, ang tinuturo natin sa estudyante agad-agad, ito yung mga axioms ni Euclid, then i-prove mo tong theorem na to. Okay? So minsan doon pa lang nahihirapan na yung estudyante. So when I teach basic mathematics, lalo na if we're discussing axiomatic system, hindi ko muna nilalagyan ng complicated concepts. So nag-start muna ako with this. Sabi ko, let's say, i-accept natin, these are our axioms. Example, axiom 1, every dog has at least 2 human owners. Okay, axiom 2, every human owner has at least 2 dogs. Okay, axiom 3, there exists at least 1 dog. Okay, so, kunyari ito yung mga axioms natin. Okay, we accept na true yung mga axioms na yan. Then sabi ko sa kanila, yung axiom 3, kung babalikan natin, axiom 3 guarantees the existence of a dog. Okay? So, axiom 3, there exists at least 1 dog. Pero walang sinabi kung meron bang human owner, na nag-exist na human owner. Okay? So, papaprove ko sa kanila, theorem 1, prove that there exists at least 1 human owner. Then, coming from those axioms, madideduce nila na, okay, true, there exists at least 1 human owner. So, they have the proof. And when we write proofs, kailangan malinaw. Because remember, mathematics is a language. Okay, so kung kailangan i-paragraph, sentence yan, paragraph form na elegant, gawin natin. Kasi mathematics is a language. Okay? So, sort of dito, makikita nila na, okay, that's the meaning of deductive logic. Okay, and sabi ni James Sylvester, mathematics is the music of reason. So, in this side, you have the theoretical or pure mathematics. Okay? So, sa theoretical mathematics, maraming branches. Okay? Merong mga foundational mathematics like set theory and logic. Meron din namang mga different branches pa. Yung mga old schools ng mathematics, hinahati-hati nila yung mathematics into 3. Algebra, which is the study of structures. Geometry, study of shapes. Okay? Analysis, study of changes. Kasama dun sa analysis yung calculus. Okay? So yan yung parang dati, may mga Gryffindor, Slytherin, Harry Potter houses. So, yun yung different houses, old houses ng theoretical math. But now, of course, may mga intersection na yung mga yan. So, we have the theoretical math, and we have, at the other side, different application areas. The sciences, physics, biology, chemistry, engineering, social sciences, business, even arts. Okay? Then, you have applied math na nagbi-bridge ng 2. Okay. Gusto ko sigurong, before ako idiretso ko yung talk ko, I want to clarify na hindi talaga kayang isulat ng ganito yung math. Kasi, in general, mahirap lagyan ng boundary ang applied math at theoretical math. Minsan, ano ka ba? Applied math ka ba o pure math? Yung isang tao, hindi ko alam kasi I do both. Okay? Minsan mahirap lagyan ng boundaries. But siguro, it's also good na alam natin kung ano yung mga goals ng dalawa para sort of ma-distinguish natin kung ano yung ginagawa natin. So sa theoretical mathematics, what they do is, yung goal nila is to improve the language of mathematics itself. Remember, math is a language. So improve yung field ng math. Okay? With or without thinking of the application, improve natin yung mathematics. Okay? So that's the goal of pure math. And sa applied math, of course, the goal is ma-apply yung mga different mathematical methods, techniques, theorems para ma-solve yung real-world problems dun sa application areas. Okay? So that's the goal of applied math. And meron ding iba pang differences yung dalawa. The first one is theoretical math is based on, sinabi ko kanina, deductive logic. From the different premises, meron kang ma-infer na conclusion. Okay? So, yon. Kung makikita nyo, ibang-iba siya sa sciences. Kasi sa sciences, what we do, we get sample 1, sample 2, sample 3, then minsan we generalize. Okay? Although hindi yun ganun kadali. Okay? So, ganun. So, usually ginagamit natin induction. Okay? So, kapag ganun, medyo may hirapan tayo. Kasi mathematics ay deductive. Some of the sciences, or most of the sciences, ang kanilang technique ay inductive. Okay? So kung applied math ka, if you're doing applied math, hindi lang deductive logic dapat yung alam mo. So here, magkaiba na sila ng philosophy. Theoretical math, deductive lang. Sa applied math, if we're going to apply mathematics sa sciences, specific sa sciences, we need to add additional philosophy. So that additional philosophy is called falsification, which I'm going to expound later. What is falsification? Okay? Now, if i-apply naman natin ang mathematics sa arts, okay? Therefore, hindi lang dapat deductive logic. We also need to include, kung applied math ka, the philosophy of aesthetics. What is beautiful? What is amazing sa paningin ng tao? So, we have different philosophies on that. Which is, I think, hindi kayang sagutin lang ng deductive logic. So, anong ibig sabihin dito? If you're doing applied math, you also need to consider the philosophies used dun sa ibang areas. Okay? Okay. Now, sabi ko sa inyo kanina, it's very difficult to get the boundaries between pure math or theoretical math and applied math. And actually, kung titingnan natin, may intersection talaga sila. So you have here, parang applied math na medyo pang theoretical, merong applied math na mas malapit sa application areas. One of the techniques ng applied math na medyo siguro mas malapit sa application area is mathematical modeling. We model different real-world problems using the mathematical language. We model. And I'm going to give you example mamaya. So medyo mas malapit siya sa application area. The other one is, kapag medyo malapit ka siguro dun sa theoretical math, ikaw yung applied math na gumagawa ng algorithms, na nag-a-analyze ng model mismo, gumagawa ng simulation na medyo theoretical. Okay? So may mga ganong side na applied math. Hindi talaga siya, applied math ako, isipin nyo na baka mas malapit siya agad dun sa application area. May iba na mas malapit dun sa theoretical math. They're working closely dun sa mga pure mathematics practitioners. Okay? So yan. So you have the two.